The gift grant and contract report is approved. Now we will move on to our research presentation.
One of my great honors in the role of Vice President is to highlight the research and scholarship of our faculty. Today, we will hear from Professor Emilio Moran of the Department of Geography in the College of Social Science. Emilio Moran joined MSU in January of 2013 as a Hanna Distinguished Professor associated with the Center for Global Change and Earth Observation and the Center for System Integration and Sustainability. He was until 2012 Distinguished Professor in the James H. Rudy Professor of Anthropology at Indiana University. Professor Moran is the author of 11 books, 16 edited volumes, and more than 200 journal articles and book chapters. His research has been funded by the NSF, the National Institutes of Health, NOAA, and NASA for the past 3 decades. He currently holds 4 major NSF grants totaling nearly $7.8 million. His 3 latest books, Environmental Social Science, People and Nature, a 2nd edition, and Human Adaptability from Westview, address broad issues of human interaction with the environment. He is a fellow of the Linnean Society of London, a fellow of the American Association for the Advancement of Science, and was elected to the National Academy of Sciences in 2010. He was appointed to a 6-year term on the National Science Board in 2016. In this role, he provides advice to the National Science Foundation and the nation on major decisions in science and technology. Professor Moran?
Hello, I hope you can hear me.
Yes.
I am delighted to be here and to share my research for the last 5 years since coming to MSU. I will speak today about the 2 most recent grants. One that is in the final year, funding research on food, water, energy issues in the Amazon Basin. And then in October, we got news of a new 5-year grant, also from the National Science Foundation, to continue that work that we started in the last 5 years. What we're trying to do in this research is to meet the needs of about 680 million people across the world that are off the grid, that don't have access to the national electrical system. I've been working on issues of infrastructure in the Amazon for more than 30 years. I started by looking at road building when they first started doing so to open up the Amazon to development. And it is the road building and homesteading that came along with it that drove much of the deforestation in the Amazon rainforest for the last 30 years. And that has been a focus of a lot of my work in the past that led to the National Academy election. 10 years ago, they started developing hydropower in the Amazon region. And I realized that perhaps now hydropower projects stood to transform that part of the world that we value so much in the rainforest, as much as road building did for the previous 30. So I began to look for funds to address those issues. Dam construction is different from road building in that it does not directly lead to deforestation, but is associated with flooding of forests in the reservoir areas, and it also provides greater access to people moving in and cutting the forest. Environmentally, hydropower tends to disrupt fish migrations. It blocks the movement of sediment in the river and therefore impoverishes the river ecology. And it tends to devastate floodplain farming and fisheries as a result of blocking the river. Socially, perhaps the impacts are even greater. Population doubles near the construction area. Local facilities for public services are overwhelmed by the number of people that arrive to build the thing, and things like dengue fever, malaria, STDs, and violence run rampant. Hydropower is not something new to the Amazon. It's not new to the United States. There are a total of 82,000 dams in the US alone. 672 are considered large dams, and 2,000 of them are in Michigan. So it is an important issue, an important source of energy. It is no longer as big a source as it used to be. Once upon a time, back in the 30s, during the heyday of hydropower construction, it accounted for 40% of the US electrical supply. Today, it's only 9%, has been replaced by other sources. What is more common today in the US and in Europe is dam removal rather than its construction. To date, more than 3,000 dams have been removed in Sweden, Spain, Portugal, UK, Switzerland, France, and more than 500 dams have been removed in the US just in the period from 2006 to 2014. Just as we stopped building more large hydropower projects in North America and Europe, a tremendous boom in construction began to occur in the global South and primarily in developing countries. An estimated 3,700 dams of more than 1 megawatt are planned or under construction at present. It is an important source of energy. It is renewable. However, as I've mentioned already, there is not entirely benign. Why the Amazon? Well, the Amazon is one of the largest hydropower systems in the world with a tremendous potential. 61% of the total potential for Brazil is in the Amazon Basin, and our current project has been studying the 3 most important basins for hydropower production. And so our team of hydrologists and climatologists have been looking at the details of that climatic hydro connection and see how we might be able to benefit from all that potential hydropower, but without the huge social and environmental impacts that have been glossed over during much of the construction so far. And for Brazil, this is very important because second only to China, Brazil is most dependent in the world for its electrical supplies. Currently, 67% of its energy comes from hydropower. And the focus of our work for the last 5 years was the Belo Monte Dam in Brazil, in the Amazon region. It's the 3rd largest in the world. Just to give you an idea of proportion, it is twice the size of the Grand Coulee Dam, the largest in the United States, and 5 times bigger than the Hoover Dam in Colorado. So this is a very large project, which has had enormous impacts, which is the subject of our study. We found that they had to resettle 22,000 people away from reservoir and river areas that would be flooded. The community supporting the building of the dam doubled in population in less than a year, leading to a tremendous increase in cost of living for the local population. It increased depression, the use of drugs. Public service was completely overwhelmed, and there was no improvement in the water and sanitary situation as was required by law from any new infrastructure development. The impacts were no less severe in the agrarian sector, which has been the focus of my work for many decades. Deforestation increased enormously with no reforestation associated with it. Land use did not change, mostly kept on the same trajectory, mostly focusing on cattle ranching and cocoa. There was tremendous decline in farm labor because much of the farm labor left to work in the dam, and therefore this led to a decline in food production in the agricultural sector, which meant that the area became more and more dependent upon food imports, which were very expensive. The one good thing to come out of it was a paving of roads that had been promised and never done before. And there was a big inflow of capital investment, but it was very brief for 5-6 years, and then that capital left. A tremendous focus of our work includes engineering. From the very beginning, I thought that to address the needs of off-grid communities, we need to find something better than dams that still can take advantage of the hydropower potential of that region. So our engineering team here from MSU has been working on developing an Instream turbine. This would be a turbine that goes in the river without requiring a dam to produce energy. And that such a in-stream turbine would just float in the river, allowing the fish and boats to move along the river freely, or it could be encased in cement in a rock solid structure. And also the engineering team developed a new idea, which was not part of the original design, which was to develop solar farms floating on existing reservoirs. The advantage is that while an Instream turbine can generate power throughout the day from the moving of water along the river, solar can produce energy during the daytime. And in a tropical region like the Amazon, there is tremendous amounts of solar power available, heretofore undeveloped. And this could provide more energy during the peak hours of daytime when more use of energy occurs. This solution is interesting because it means that we can meet the needs of local people who are off the grid and have no access to inexpensive energy, but also because it can produce energy for the national grid. So our engineering team has come up with a set of potential solutions, some for off-grid communities, others for on-grid communities, and also thinking about the financial interests of the energy sector, which means that we want to be able to combine the Instream turbines in new sites and solar panels floating on existing dams, once already built. This means that those solar panels can provide the production of energy to make up for any decline in the hydropower production that occurs during low water periods. For example, the dam that we have been studying is, as I mentioned, 11 gigawatts of power, but in fact, so far, he has never produced more than 4.5 gigawatts because due to climate change, there has been a decline in river levels and they have not been able to produce energy to their full potential. Instead of building more dams to make up the difference between 4.5 and 11, we are proposing that these in-stream turbines and solar panels can more than make up for the difference, making any new dam construction unnecessary. So in short, our solutions are that our combined solution of solar and in-stream turbines can produce energy at 1/10 the cost of a similarly sized diesel generator, which is what people currently have when they're off the grid. Covering just 10% of existing dam reservoirs in the Amazon with floating panels, we generate 30 gigawatts of power, which is more than twice the amount of energy that is expected to be produced by all the dams that are planned in the Amazon, which is 145 dams that are currently being planned for the region, which could devastate the river and the fisheries of that region of the world. We can also produce about 63% of the total energy planned from conventional hydropower. In the Amazon, it could be harnessed using the in-stream turbines. And we have a paper on ways to publication about this estimation. So our team of MSU scientists from social science, natural science, communications, and engineering have been working together to advance these solutions by working together in a very convergent manner, which is the focus of our new work in the next 5 years. Our innovative solutions for serving off-grid communities have potential to meet the needs not only of 200,000 households in Brazil, but of 650 million people across the globe, including parts of the US, who are currently saddled with expensive and unsustainable energy options. You can see some of this work in a recent paper in the Proceedings of the National Academy of Science, and I thank you for your time today. I'm open to questions.
It was a remarkable presentation, Dr. Moran. I'm so impressed by the work you're doing, and I think it really epitomizes some of the things we're trying to do at Michigan State. I mean, the scope and scale of this, and I think the fact that this source of renewable energy, hydroelectric power, which I think many people feel is at least it still remains an important solution. Some of the consequences of it that are unintended in terms of, as you've talked about, in terms of the dams and so on, I think make your solution obviously an elegant one when combining with solar power, which obviously makes tremendous sense in equatorial regions. So very excited about what you're doing, and I look forward to learning more. Congratulations.
Yeah, our team is very excited. And I think NSF also is excited, which is why we'll be successful twice in a row.
That's always important. That's very, very important to have the agencies inside it as well. But it's great stuff. And again, thank you for sharing it today. If there's no other questions any other questions from the board members or comments, thank you again.